What's up, Lancers? Here we are in chapter 12. In this chapter, we'll be talking about lots of circles and all the cool lines that we can do with circles as well. Okay, doke. So, I guess a couple things to review. Just what's a ray, what's a line. So here's an example of a ray. If you remember, it actually has an endpoint and it has and it goes on infinitely in one direction. Talking about a line, right? There's an example of line. It goes on infinitely in both directions. So your first key term of this chapter is called a tangent. Or what is it when a line is tangent to a circle? Well, first of all, if a line goes through a circle, right, it'll always go through or intersect two parts of that circle. So a tangent is a line that doesn't actually go in the circle, and it just intersects with one point exactly on the circle. So it never goes inside, it's just barely passes through the outside of it, okay? So that little point that I just boxed there, that's called a point of tangency. And if I scroll down here to this theorem, take a look at this. The thing about a tangent, right? So if you know that a line is tangent, so here you go, AB is tangent, that line is always perpendicular to the radius of the circle, right? So if I just drew another line here, let me change that color, and here's that radius again. Oops, that didn't look very good. Let's try that again. There's a radius, and I said this blue line is tangent. You would know that that is perpendicular to the radius, forming a 90-degree angle. Now, let's take a look at doing a proof. Just kidding, no proof. All right, moving on. So we're going to take a look at this problem here, and it says multiple choice question, which I got rid of that multiple choice. And basically, we're just going to say, what is the value of x given this problem? All right, so here's our x right there. We are told that that guy and that guy, those two lines are tangent. And so what that means is that is perpendicular and that is perpendicular, therefore we have 90-degree angles. So let's take a look, right? So what do we have? We have a four-sided shape. That should tell you that is a quadrilateral. So n minus 2 times 180, which gives us a total interior angle degree of 360. Now let's add up our angles. We are told that that central angle is 117. We have angle L, which is 90 degrees. We have angle N, which is 90 degrees. We have angle M, this guy way over here. And that guy is, we don't know, right? That is our X. And add those up, we have a total of 360. So you do some magic, you add these guys up, you bring them to the other side, and you will find that x is equal to 63 degrees. All right, so hopefully that makes a little bit of sense for your first one. I'll do this one real quick. What do you, or how do you find x? Sorry, this is a little laggy here. I'll just keep talking. So remember, x is this guy way out here. We are told that this line is 90 degrees, but now we have ourselves a triangle. All right, so how do we find x? We do the same thing. We simply just say angle D, all right, which is 90 degrees. Now we're going to take a look at, we're going to add that guy in. And so we say 38 degrees. And we're going to add x in, right? That's our angle E. And so, and that all together now equals 180 degrees. So add these guys up, throw them over there, subtract, of course, and now you have x, the value of x. Lastly, I'm just going to talk you through this problem, and that'll be the end of problem or video number 1. And in this case, it says the CN Tower in Toronto, Canada has an observation deck of 447 meters above ground level. And how far is it from the observation deck? This is your observation deck way up here. to the Earth's to the horizon. All right, and that's basically when we're talking about the horizon. They're just talking about that point right there. So notice that T, that's going to be your observation deck. E, that's your horizon. And they want to know what that distance is, right? What is that? So let me clean this up a little bit for you. Alrighty, so take a look at what we're going to look at here. If I were to zoom in on this picture and the work right below. So this here is our distance from the observation deck to the Earth. And we're also told that the Earth has a radius of 6,400 kilometers. So there's 6,400. All right, oopsies, too many zeros. This is also 6,400 here. And this guy is simply x. So as you can see, it's just a matter of using the Pythagorean theorem. All right, we're going to add these guys up here. And that's that move right there. All right. That is your c squared, if you will. And how do we know? Because remember, this is our 90 degree. So that's A and that's B. So there you go. So this would be your A right here. That's your B, the center of the Earth. And just kind of use your calculator to work your way all the way to that answer there. So 76 kilometers above the Earth. Okie doke. So hopefully that video was helpful. That's part 1, and I will see you at the next one. Thank you.